Alright, so I've got a new project or something I'm trying to get to, and it kind of jumped the gun a little bit, but it's kind of because I moved one thing which made something else more difficult, which caused the third thing to get delayed, and then the fourth, anyway, just one thing led to another. Um, so first I picked up this small Harbor Freight compressor um, for 50 bucks, and it works, builds pressure, holds pressure, tank didn't explode, knock on wood. So got that. Second thing, big boy back there, the big Goodyear tank, superimposed finger right there behind the oxycylinder. That's the old Sailor Beal that I'm hopefully gonna get. I hydrated the tank out back in July to make sure it's gonna be safe, because the tank is an ASME, American Society of Mechanical Engineers. Anyway, it is a stamped tank, but it's also from 1966. So I first don't want to mount that anymore in my shop, because that's a pressure vessel and a potential bomb. Along with that one, along with that one, along with all my gas cylinders. So I don't want that in my shop. In case something does happen, I don't really want to be right next to it if it has an issue. Also noise, also space. The shop isn't that big. It's only 19 by 19, and truth be told, most of the time it has trucks in it. But eventually I'll get that, mounted in place. I need to come up with a motor for it, which I think I have. The compressor's in my other shop. I want to strip and paint the tank and get it all cleaned up and plumbed. I'm waiting on a new safety valve for that. Meanwhile, my little cabinet sandblaster is in the loft up there. But compressor's down here. A little compressor can't run it. Also checking tire pressures, everything else. Airing up tires is always a pain in the ass, because the shop's normally locked. All the vehicles are on the other side of that wall or behind there, and it's just not that convenient to always drag the compressor out, plus the hose, plus the gauge, plus the, everything. It's just kind of a pain in the ass. I'd like it to where I can, go to the other side of that, of my wall, open up a little door, pull out an air hose, or walk out there with a little curly Q airline, check my tire pressure, and when I'm done, either, just leave it out there, put a hook up if it's out in the summertime, and be done with it, and not have to worry about getting the compressor aired up and waiting for it, and then all that fun stuff. So what I'm going to plan on doing here is I've got a whole bunch of copper. Now I thought about this by solvent weld quite a bit of PVC, being an irrigation contractor. PVC is not, well, I think the OSHA, from what I read, is somewhere about anything over 8 feet or 10 feet. You can use PVC, but it can be, can explode, lead to shrapnel. Not fun stuff. I've seen people do it. But anyway, so my choice was Type M copper. For me, it's gonna be easy to work with. It's not gonna, rust or anything like that. I can go galvanized or black iron. I have a manual threader. I got a couple manual threaders. I could have threaded it, but I went Type M copper. So there should be 60 feet of a 1-inch Type M. There is a 1/2 inch, and then what I'm going to do is I'm going to run a 1-inch line. I want to have a drop up in that corner, and I want to have a drop up above that for the storage loft area, because that's where my sandblaster's at. So I want to have a couple drops up there. I also want to have at least have one drop inside for now. Like I said, this garage is normally where I have trucks parked, and then really I want to have a drop outside and a drop off to the side where the service comes in. So 2 outside drops. Now the outside drops I'm going to have set up that in the future I could always go to a 1-inch knuckle fitting, Chicago knuckle fitting. That's what we use like our tow behind air compressors. But otherwise, I got a couple cheap regulators, short curly Q hose, just so that, like outside or anything, I can dial down the pressure that I'm run back to the tank or anything like that. So that's the plan. Big compressor will probably go outside the wall at some point. So that's where we're going to start. I'm going to grab a couple other things. We'll bring you back to discuss how we're going to do our outside air connections. Alright, so let's talk about how I'm going to enclose my outside air connections. So these are all old irrigation controllers, mostly mostly hunter and rainbird, with actually emphasis being on rainbird. There's some weathermatics, there's a couple of metal cabinets down there. Anyway, so I get these for free because they're used, and sometimes we like to use them as cabinets, but let's see what we got. So the first thing I'll say is there is a difference between indoor and outdoor controllers. So this controller right here would be an indoor. No, there's no lock like this one. So this would be an outdoor. So it has a lock, and then it also has an internal transformer. If I flip this open, when I say internal transformer, there's our connection for 120. There's our step down 24N. Then we have our, this being a modular controller, an ESP. We have our modules up to, on these older ones, 13 stations. Now if I flip, all right, so I will say, you know, the difference between these two is outdoors have internal transformer, so you can either hardwire this in, or you can use a pigtail that just goes to, you know, your standard grounded pigtail that you just plug straight in the wall or into an extension cord, and it has a lock. That's an outdoor. Indoors have what we call a wall wart. So you can see, still has a rainbird wall wart. Sometimes you see them mixed up. They're pretty much all do the same thing. Long as they're 24 volts, it could be a hunter, it could be whatever. So this are indoor. So you notice that the cutout for the inside label, if I can get my, has a provision for a lock, but it's not there. And then we have the wall wart. So indoor wall wart, no lock. Outdoor internal transformer, lock. Now, there's no other takeaway from this is that if you buy an indoor controller, and because indoor controllers are generally cheaper than the outdoor controllers, and you install an indoor controller outdoors, and you warranty it, so there's an issue, a lot of times they will refuse warranty on it. At least I've heard that, at least from Toro. Why, I don't know, because if you look at all the ceiling edges, there's no difference between indoors and outdoors minus the lock and the transformer. Same cabinet design. So let's move over to, so those two are rainbirds, just for illustration of indoor versus outdoor cabinets. This is a Hunter Pro-C. Same thing, this you can tell, lack of transformer. This was an indoor, lack of lock. This was an indoor controller. And then we have the bigger controller, and this is the one where it's really hard to tell because this could be indoor or outdoor, but I'll generally tell you that if it isn't punched out, no transformer, this was an indoor. Now this was an ESP-LX. Anyway, so I've got a few of these. Now, what I want to mount in there is, I've got a swivel, so I'd like to come into the back of my box. If this box completely gutted out, I'd like to come in the back of my box with my 1-inch copper female adapter, so 1-inch FIPT, come to that, reduce it down to 1/4 inch, and I thought about putting a swivel on there from Harbor Freight, and then put an air regulator, and then have a quick connect, and then I can either have a, you know, a cheapo dollar hose, literally like a couple buck hose with a air gauge, or, you know, blow off tool, whatever. But that's what I'd like to have. I don't necessarily want to have the hose in here. I really just want to have an air regulator. Swivel, we'll see. It's just more to have access and don't have to be perfect on everything. And then a quick connect, and then I can also keep like a tire pressure gauge, air chuck, blow off tool in here. That's why I like to do it. Also, that way my quick connect can stay out of the weather. And I mean, they're going to be brass, but that way I don't have to worry about, you know, rust or corrosion. Really, I just want to make sure I can keep a tire pressure gauge and other stuff in them. Also, the box adds limited protection. So, I like the Hunter cabinets. We're working with Hunter controllers. I really do like the Hunter ones better. I'm more of a Hunter fan than a Rainbird fan. So I've got a few of them, so I only need 2, so I might take those. There's 2 smaller Hunter cabinets on the bottom right there. Again, superimposed finger, but I think those would be too small. Those are still, I think those are almost brand new, so I want to take those. There's some weathermatic controllers down here. Just don't like this. I don't like the ridges. I like that Hunter controller where it has a nice smooth, nice smooth lines, and so I might do that. So I think that's what we're gonna do. So I'm gonna get a couple of these cabinets out, get them gutted out, and that's what we're gonna use. All right, so I've got. So I'm working on getting the first part of the airline or the air system started up, and I'm just starting from one end or one corner. Now this is the wall adjacent to the man door where I want to have the have a point to be able to pull air out of the shop for blowing stuff off outside or really anything air-wise. I could always use it if I wanted to run up to the house and blow something off or run a nail gun in the house or something. It's only about 30 feet away. Anyway, so usually, and I didn't do it when we had the service put in here, but I'm probably gonna go back through because the walls are 2x4 walls, 12-inch centers, and there's outside sheeting, and then there's furring strips in the actual cement board, lap siding. And when I did the siding work, we had to fur it out because the old garage on top is shiplap, and down here where we patched it, it's plywood. So whenever I drill holes through this, I like to go through from the, cut an opening like this, like we did the light up there. That was more for blocking, but this one just because I like to be able to seal this out because we have a problem with ants around this area, and so ants like to find any way they can get in. So I like to seal, once I have everything done, I like to seal from in here, make sure the insulation's back, probably spray foam this, and then just put my patch in. That's why I cut it between the studs, and just enough that I can drill this out and do everything I need to do. So, and then what I'll probably do is I'll probably put the pipe through, or I'll get it so I can patch all this up, and then, well, anyway, I think you understand my point, is I want to be able to patch to the outside wall and be able to spray foam this and make it all bug tight and resistant and all that. Now the next question that's going to come up is, okay, well, if I'm running a copper pipe out, how do I get, obviously I've got in the same plane, say, of this wall, I have to step over these conduits. At the time, the reason everything is on surface is A, it's a shop. B, at the time when I did everything, there wasn't money in the budget to put power out to it immediately. And everything is 2x4 framed on 12-inch centers. There's a 4x6 halfway up, and there's just gonna be a lot of drilling. So what I have are these copper bells, or that part being a bell, but anyway, just a pipe support. They look nice, and I might have to block this out just a hair, just to give myself, I might have to probably wrap this because this is steel, and it's grounded, or bonded, I should say. And this is copper, so we don't want these touching each other for electrolysis reasons. So that's what we're going to do, and steel would lose. That's been my experience when you have copper and steel together, is that the steel loses. But I don't want to take that chance of having an airline with I don't know. To me, I don't want to take that chance. So that's where I'm going to start, is we're going to go outside and see where that puts us so we don't drill it right on the lap seam. There's my finger. So drill outside in, we'll measure it up, make sure that we're not going to drill it on a seam if I drill it out. Also, I don't want to blow out a chunks on a cement board. So let me start working on that, and I'll bring it back once we start going. Alright, so I had to refilm this portion up because I realized I was holding my camera vertically, and when I put this all together in the videos, it screws everything up, and there's something sticky on the bottom of this. So this is my pipe clamp. It's copper. It got this old bell. I thought it looked kind of neat. Like $2 each. And I'm using my spacer block, which this happened to be 3/4 inch plywood, because I thought I grabbed 1/2 inch scrap I had laying around. It was 3/4. That's fine, because you need a little bit more safety distance. Alright, so I'm using this for mock-up. Reason being, I have an open panel. I will tell you that copper is conductive. That's a bus in the back. There are 2 lines coming in. And this has just been open this way because it's only me that comes in here. There's generally not a whole bunch of stuff around that's going to cause a problem, but right now you can see copper pipe lean against that. It makes contact. It becomes hot or electrified. You touch it, you ground, you're done. So that's the fun thing about working around an open panel like this, and same thing for pushing fish tapes into it, anything like that. So got this run done. You can see there's my standoff in the back. got my pipe clamped, goes at the wall. I had to swedge this out quite a bit. You can just see how it kind of belled out because for some reason that T, I didn't verify it, did not fit my adapter going down 1/4 inch. So what I'd like to talk about is, you can see I got my T going up, got our support clamp. It's going up to the attic for the drop. Had to move all my crap off my shelf to get this run done. But I did want to talk about is how I kind of pipe fit and figure things out. I generally don't use a tape measure for a lot of things. I just try and physically fit things together. But see if I can get up there holding the camera while doing a couple different things and see if I can make the sense of this. So let's try and do this. Up the ladder we go. Okay, so now if I look down, you can see all the conduit I've got going into that box. All goes over here, got extra conduit in the back, and that's kind of the reason I picked this height, was that when this goes around, it misses just a lot of the other stuff. So, right now, we're kind of set up for, going up. We're going to go up in the attic later on and work on that. But, meanwhile, when I was looking at this is, I want to go over to that wall. So how did I figure out, the length and then the standoff and making sure this all fits? Well, let me see if I can get my pipe. You have to bear with me here as I try not to, A, put it into the bus, B, try to drop it, and C, try and get it held up with one hand. Okay. So, there's my pipe going over to the wall. I'm using a stub, just a short piece. Like, all the pipes had dents in them, so I cut off, that's the tail end of that. So if I look over here, if I can get this right, you can see I got some slack in that. So if I can, I'm gonna do this. This is gonna be a crappy video for that reason. So generally, if you get the idea, when I put this against the wall, then I'm looking at, if this is the back, or if that's the back of my wall, and this is all standoff, I'm trying to basically just figure out, so what I did was I took this part that I'm holding, put it on the end of it, put the 90 on there, and shoved it against the wall, then marked it and cut the pipe. That's how I'm figuring everything out. You can also see I've kind of overheated a couple fittings. I had to do this one vertically, and that's why it looks like that. So I just want to share kind of how I go about trying to pipe fit everything together. Like, a lot of times, I think I mentioned earlier, I work with PVC, and I don't normally use a tape measure. A lot of times I just use a reference stick, or something I can just stick inside, use my thumb, mark it, cut it, and I just kind of fit things together as they go together. I'm not so worried about trying to make sure everything's, down to a 1/16 or whatever. So, thought I'd share that. So let me get this soldered up. Okay, so it's snowing. It's February 12th. You can see, we've got white snow everywhere, maybe about 1 inch. So I'm going to pop this open, and you can see I've got my airline coming in. So I've already gutted out this cabinet. I'm going to fill up the two, where's my finger? These two holes I'll patch up. But anyway, so there's my 1 inch FIPT connection coming in, copper. And then I'll reduce that down, have my air regulator on a swivel, be able to pull it out, hook up. So that's then when I'm done, it's all set. So I wanted to show that. All right, so day 2 or day 3, I think it's day 3. More snow coming down, made it out. I got a rollback stuck in the neighbor's field. But anyway, so I should have narrated this while I was moving around. Anyway, so I got a line coming over, T comes down, goes at the wall. There's actually 2 holes. I drilled up this wall, it's a 2x4 wall. So I think what I'm gonna do is I'm gonna go ahead and put the conduit and run it out. This is basically, the idea is this is gonna be for incoming air to the compressor, or I should say to the shop. Looks okay, kind of funky in a couple spots. I only had one person, which is myself, to run on this. So I ran it down, and then you can see my hole way down, where's my finger? Way down there, drilled and mounted the air box on the outside. So it's secured. Had to go a little bit thicker because I'm inch and a half, about a 1/4 inch thicker on the back wall on my standoffs. I don't know what I got behind my tape measure, but I was just off a little bit. So that's, oops, sorry about that. So that's where we're at with that. It was kind of funny. These damn, it seems like the only jackets, I got these damn masks, for, going to the stores and stuff. And this one I grabbed in my pocket because usually, grab a paper towel and I'll wipe down the solder joint and just so it cleans up. And I grabbed a mask and apparently the mask melts. So then I had to heat up and try and scrape that off. And then I had a bag, I think it was that bag right there that, that it got stuck to because of the hot joint and it fucking stuck and melted and stuff like that. But, anyway, so I think I'm going to pull a piece of conduit over tomorrow or something and down, and out the wall, and that'll be the disconnect for or I shouldn't say disconnect, but, that'll be where the, air compressor plugs in. The 703 Sailor Beal single or dual, let's see, 2-cylinder, what am I trying to say? Not two-phase, basically, god damn, I can't even think of it. Two piston, I won't say two-phase, but takes basically the air has to go through two different pistons to finally make it out of the compressor. Anyway, that takes a two stage. There we go. Two-cylinder, two-stage compressor is what the 703 Sailor Beal is, and it takes a 2-horse motor. The motor itself, I think, yeah, this one right there, off a Flint and Walling pump. Anyway, I think the service amps on are 22.5, so I can pull some 10 gauge wire, got some stranded wire, pull it through. Anyway, so that'll be the future. And I don't know, I might have that plug in, like a 250 volt plug. I might hardwire it, I don't know yet. So that's kind of where that's at. So I'll probably pull a piece of conduit over, and then for now, it's just going to run through the little cheapy compressor. I do have most of the parts to put that one together. Just need to do it and strip the tank to paint it. But anyway, so I thought I'd just give you a quick run around to that. So that's where we're at, and that's where we're wrapping up for tonight. It's dinner time, it's shower time, it's all that fun stuff, and so that's just a quick update on the progress.